What's up? This is Sir EJ and welcome to another math tutorial. In today's topic, we will be discussing all about arithmetic series. So arithmetic series is the sum of terms in an arithmetic sequence. So there are two possible solutions or formula that we can use to find the value or the sum of the sequence. So we have S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n, wherein a sub 1 is equal to the value of the first term, n is equal to the number of term, a sub n is equal to the nth term, and s sub n is equal to the sum of the arithmetic series. The second formula is s sub n is equal to n over 2 times the quantity of 2 times the first term plus quantity n minus 1 times the common difference, wherein a sub 1 is equal to the first term, n is equal to the number of term, d is equal to the common difference, s sub n is equal to the sum of the arithmetic sequence. So let's now have an example. Find the sum of the first 20 terms of the arithmetic sequence 15, 19, 23, and 27. So let's have solution number 1. So using solution number 1, we will find the value of the 20th term using the formula of the arithmetic sequence a sub n is equal to a sub 1 plus quantity n minus 1 times the common difference, wherein a sub 1 is equal to 15, the first term, d is equal to 4, the common difference, by subtracting 19 minus 15, 23 minus 19, 27 minus 23, and that is equal to 4. And n is equal to 20, which is the number of terms. Then we will substitute n is equal to 20 equals the value of the first term, a sub 1 is 15, plus quantity, the value of n again is 20, minus 1, times the value of the common difference, which is equal to 4. And then bring down a sub 20 equals 15, 20 minus 1 is 19, then times 4. And then bring down 15, 19 times 4 is equal to 76, and then a sub 20 will be equal to 91. So the 20th term is equal to 91. After that, we will use the formula of the series. So we have the following value, n is equal to 20, a sub 1 is equal to 15, and the value of a sub n is equal to 91. So we can use the formula for the arithmetic series s sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. We will substitute the value, so we have s sub 20 is equal to 20 over 2 times the quantity of the first term, which is equal to 15, plus the value of the last term, which is equal to 91. And then we will simplify. S sub 20 is equal to 20 divided by 2 is 10. 15 plus 91 is equal to 106. And then bring down S sub 20. 10 times 106 is equal to 1060. So the sum of the first 20 terms of the arithmetic sequence 15, 19, 23, 27, and so on is equal to 1060. So for the same problem, find the sum of the first 20 terms of the arithmetic sequence 15, 19, 23, and 27. Let's have solution number 2. So we will identify the given. So the value of the first term is equal to 15. The value of the common difference is equal to 4 by subtracting the second term minus the first term, third term minus the second term, and fourth term minus the third term. That will be equal to 4. And then the value of n is equal to 20, and then the value of s sub n is unknown. So we will use the formula of the arithmetic series, which is s sub n is equal to n over 2 times the quantity of 2 a sub 1 plus quantity of n minus 1 times the common difference. And then we will substitute the value. S sub 20 is equal to n is equal to 20, so 20 over 2 times the quantity of 2 times the value of the first term, which is equal to 15, plus the value of n, which is equal to 20 minus 1 times the value of the common difference, which is equal to 4. And then we will simplify. S sub 20 is equal to 20 divided by 2 is equal to 10. And then after that, 2 times 15 is equal to 30, plus 20 minus 1 is equal to 19 times 4. And then after that, bring down S sub 20 equals 10. Quantity of 30 plus 19 times 4 is equal to 76. And then 30 plus 76 is 106. And then 106 times 10 is equal to 1060. So the sum of the first 20 terms of the arithmetic sequence 15, 19, 23, 27, and so on is equal to 1060. Okay, so let's now have our next example. Find the sum of the first 24 terms of the arithmetic sequence 15, 10, 5, and 0. So solution number 1. So we will use the formula of the arithmetic sequence to find the value of the 24th term. So we will identify the given. The first term is equal to 15. The common difference is equal to negative 5. 10 minus 15, 5 minus 10, 0 minus 5, that is equal to negative 5. And the value of n is equal to 24. We will substitute the values in our formula. So we have a sub 24 is equal to the value of the first term, which is equal to 15, plus n is equal to 24, and then minus 1 times the value of the common difference, which is equal to negative 5. Then simplify. Bring down 15, 24 minus 1 is 23, and then 23 times negative 5 is negative 115, and the negative 115 plus 15 is equal to negative 100. So the value of a sub 24, or the last term, is equal to negative 100. And then the next step is to solve for S sub 24 using the formula of the arithmetic sequence. S sub n is equal to n over 2 times the quantity of first term plus the last term. So we will substitute the value. So we have S sub 24 is equal to the value of n, which is 24. So that will be 24 over 2 times the quantity of the value of the first term, which is equal to 15, plus the value of the last term, which is equal to negative 100. So positive times negative will be equal to negative 100. So bring down S sub 24 equals 24 divided by 2 is equal to 12. 15 minus 100 is equal to negative 85. And then 12 times negative 85 is equal to negative 1020. Find the sum of the first 24 terms of the arithmetic sequence 15, 10, 5, and 0. So the first step is to identify the given. A sub 1 is equal to 15. D is equal to negative 5 by subtracting the second term minus the first term, third term minus the second term, and then fourth term minus the third term. So 10 minus 15, 5 minus 10, 0 minus 5 is equal to negative 5. That is the value of the common difference. And then n is equal to 24, the number of terms. And then we will find the value of S sub n. So we will use the formula. S sub n is equal to n over 2 times the quantity of 2 times the first term plus the quantity of n minus 1 times the common difference. And then we will substitute. So S sub 24 is equal to n, which is 24, divided by 2 times the quantity of 2 times the first term, which is equal to 15, plus quantity of n, which is equal to 24 minus 1 times the value of the common difference, which is equal to negative 5. And then we will simplify. S sub 24 is equal to 12 times 30 plus 23 times negative 5. So we have 2 times 15 is equal to 30 plus 24 minus 1 is 23 times negative 5. Then bring down S sub 24 equals, bring down 12 times 30 minus 23 times negative 5 is negative 115. Bring down S sub 24 equals to 12. And then 30 minus 115 is negative 85. And then negative 85 times 12 is negative 1020. So the sum of the first 24 terms of the arithmetic sequence 15, 10, 5, 0 is equal to negative 1020. So let's now have our last example. So this time we will be solving for the value of n. How many terms is needed for negative 3, 2, 7 to have a sum of 116? So we will find the number of terms. So that is n. So let us identify the given. The value of the first term is equal to negative 3. The value of the common difference is equal to 5. 2 minus negative 3 is 5. 7 minus 2 is 5. So that will be the value of the common difference. N is unknown. And the value of the last term, S sub n, is equal to 116. So we will use the same formula in which S sub n is equal to n over 2 times the quantity of 2 times the first term plus the quantity of n minus 1 times the common difference. So we will substitute. The value of S sub n is equal to 116 equals the value of n, which is unknown, over 2 times the quantity of 2 times the value of the first term, which is equal to negative 3, plus n is unknown, minus 1 times the value of the common difference is equal to 5. And then we will simplify. Bring down 116 equals n over 2 times 2 times negative 3 is negative 6 plus 5 times n is 5n. 5 times negative 1 is negative 5. And then after that, bring down 116 equals n over 2 times 5n. Then after that, combine like terms. So I have negative 6 plus negative 5, that is negative 11. And then multiply both sides by 2. So 2 times 116 is 232. And then 2 times n divided by 2 is n times 5n minus 11. And then bring down 232 equals n times 5n is 5n squared. N times negative 11 is negative 11n. And then arrange in descending order. So we have 5n squared minus 11n, 232 transpose positive, that will make it negative 232 equals to 0. So this is quadratic equation. So since we are dealing with quadratic equation, we will solve the value of n using the quadratic formula. So the given is 5n squared minus 11n minus 232 is equal to 0. So we will identify the value of a, b, and c. So a will be the numerical coefficient of the quadratic term, which is 5. And then b is equal to negative 11, the linear term. And then c is equal to negative 32, the constant term. So we will use the quadratic formula. N is equal to negative b, positive negative square root of b squared minus 4ac all over 2a. And then after that, we will substitute the values of a, b, and c. So we have n is equal to negative times the value of b, which is equal to negative 11, positive negative square root of b squared, which is equal to negative 11 to the second power, minus 4 times the value of a, which is equal to 5, and then times the value of c, which is equal to negative 232, all over 2, bring down, times the value of a, which is equal to 5. And then we will simplify. Bring down n equals negative times negative 11 will be positive 11. Then positive negative square root of negative 11 times negative 11 is equal to 121. And then negative 4 times 5 is negative 20. Negative 20 times negative 232 is positive 4,640. And then 2 times 5 is 10. And then after that, bring down 11, positive negative, square root of 121 plus 4,640 is 4,761 over 10. And then n is equal to 11, positive negative square root of 4,761 is equal to 69, all over 10. So we will be computing the roots of the quadratic equation. Since this is quadratic, we have two roots. But the number of terms we are computing is a positive number. So therefore, we will get only the positive number or the positive value of n. So we will solve for n sub 1, which is equal to 11 plus 69, which is equal to 80 divided by 10. So n will be equal to 8. So we will not compute for the negative value. So we will not compute n is equal to 11 minus 69 over 10 because the value of n will be equal to a negative number. So therefore, the value of n is equal to 8. Therefore, 8 terms of the sequence is needed to have a sum of 116.